All right, guys, so the following extra task asks us to find the value of the following if we have a function f of x that's the following and g of x that is the following. So the first thing I notice here is that they're asking me to find f of -2. So remember that this is just function notation. Whatever's in the parentheses is what you're inputting into the function. So I need to input an x value of -2 into my f function. So here is my f function. The way I like to go about it is I like to rewrite my function, but everywhere there's an x, like here, here, and here, I like to leave open parentheses. And I'll go a little bit over why after I actually do it here. So there are multiple reasons why I like to write it with open parentheses. And the main thing is that because it helps me figure out where the inputs go. If I see open parentheses very clearly, I can just go ahead and input whatever they want me to input. So it's in a way just to make sure that I input everything the right way. And secondly, it also helps me in situations like this. If I have a negative, whatever x is squared, it's a little more visually obvious on what you have to do first in order to simplify this. Because nonetheless, what we're doing here is we're just using PEMDAS. The first thing we need to check is all our work within the parentheses. So there's no work to be done inside of those. It's just a -2 and a -2. And then if I go ahead and do my exponents, well, I can start with -2 squared. Remember that -2 squared is just -2 times -2. So that
Are you writing stuff down right now?
Sorry?
Are you writing things down right now?
Yeah, I'm writing things down right now.
No, I can't see any of the writing.
Oh man, so I think this is like that one time where things don't work out really quick. Let me see, let me start. All right, so let me go ahead and rewrite my function with the open parentheses. So here I go. And then I'm gonna go ahead and input whatever my input is. So it's a -2. I know you visually couldn't see what I was explaining, but what I was trying to get at here is that as you go down your PEMDAS, there's no work to be done inside these parentheses. There's nothing I'm gonna do. Then I'm gonna go ahead and do the exponents. And it kind of helps me see that, okay, I have a -2 squared. -2 squared is -2 times -2, which is a +4. That negative has absolutely nothing to do with that exponent. So that's why that negative stays outside, and I could go ahead and do everything else on my other operation. So here I go. Now I can notice that there are no more exponents. So I'm going to go ahead and do multiplication and division. Now going from left to right, there's only one multiplication, which is that distribution piece right over there. 2 times a -2 is a -4. And then now I can see that there's no more multiplication, no division. So I'm going to do all the addition and subtraction, which is all that's left over. -4 times -4 is a -8. Don't forget to add your 1. -8 plus 1 is a -7. So you can see here that when your input is a -2 into the f function, your output is a -7. Now looking back, I'm going to double check my work. I feel like I got it down. So yeah, that's how we do that set of problem. Now, number 3, unfortunately, I skipped number 2, is pretty much the same thing, except this time we're inputting a -2/3 into my g function. So here's my g function. I'm not going to change anything. I'm just going to say, okay, g of whatever x is going to equal 5 times whatever x is squared. Now, remember, we know what x value we want in this specific situation. It is just a 2/3. And now I have to figure out the math. Is there any work to be done inside the parentheses? The answer is no, because that's just a 2/3. Is there any exponents? And the answer is yes, because we have 2/3 squared. Now, just to show you what 2/3 squared is, I'm going to rewrite it over here. So 2/3 squared is the same thing as 2/3 times 2/3. Remember, when you're multiplying fractions, you just multiply numerator times numerator, denominator times denominator. 2 times 2 is a +4, and 3 times 3 is a +9. So you notice I end up with 4/9. Now this is 5 times 2/3 squared. 2/3 squared is 4/9. And now you can see that you have 5 times 4/9. Remember, you want to multiply across if it's a whole number times a fraction. Don't forget to write it over 1. So that way you can visually see the numerator and denominators. Numerator times numerator in this situation would be 20, because 5 times 4 is 20, divided by 1 times 9, which is just a +9. So luckily for us, there's nothing that we can reduce here. We have 20/9. Now, again, keep in mind that I want you guys to leave it as a fraction. I do not want you guys to change it to a proper fraction or anything like that. It stays like that. So any questions before we start with what linear equations are on these two set of problems? All right.
No,
So, sorry.
I was just saying no.
No. Okay. All right. That's good to hear. Hopefully everything is going smooth. And if not, please let me know at a later time and I can try to help you out too as well. So today we are going to start talking about linear equations. And notice I have a lot of explanation here of what linear equations are, how to recognize them, and what they do for you. So one thing that we are going to start covering here are the connection between graphs and equations. So let's start with linear graphs. And linear graphs are pretty easy because how in the world would you know what a linear graph is? Does anybody have any clue? How can you just visually see what a linear graph is?
It's a straight line.
Yeah, that's literally it. Pretty straightforward. If I give you as many graphs as possible and you have a graph of a straight line, and keep in mind that's about as straight as I could get on this Promethean board, this is a linear equation because it's a graph of a linear line. Now, of course, it's facing down sometimes it can be facing up, but the moral of the story is that the graph of a linear equation is going to be a straight line. Now, you know automatically that if I give you something that's not a straight line, let's say if I give you something like this or anything that's not a straight line, then you know that it's not linear. Now, linear graphs are very, very straightforward in terms of recognizing whether they're linear or not. It's literally in the definition. If it's a straight line, it's linear. If not, it's not. Equations could be a little bit tricky. Now, there are multiple ways of knowing what is linear, what's a linear equation, what is not. Now, the easiest way that I have found that works is by memorizing or fully understanding what these rules are, what it can be and what it cannot be. Now let's start with what it can be. A linear equation is literally just an equation that only has operations of addition, subtraction, and multiplication of a variable and a constant. So no matter what, if I give you an equation and you look at it and you have variables that are getting added, subtracted, divided by just variables and constants, you're good to go. That's a linear equation. If you ever have a linear equation, it could also be written in the form y equals mx plus b. Now, it's pretty hard to figure out whether an equation is a linear equation following what it has to be. It's easier to decide whether something's a linear equation by what it cannot be. So keep in mind that if you ever have any of these rules over here that I'm about to go over, you do not have a linear equation. You have something that's not going to produce a straight line graph. And the first thing is, okay, their variables cannot be multiplied together. So no matter what, if you look at your equation, you have variables that are getting multiplied together, you do not have something linear. You have something different that might be what I wrote in that example. It might be a problem, it might be something different. All you need to know is that it's not linear. A second rule is that your variables cannot appear in the denominator. If you're ever given an equation, and again, you see a variable in the denominator, you do not have a linear graph. You're going to get some other kind of graph. And of course, your variables only have to have an exponent of 1. So look at your equation, look at all the variables. Keep in mind it's the variables. Check to see if they have an exponent of 1. If they do, you might have something linear, or more than likely, of course, if you follow all the other rules. Now, one thing I want to be sure is to make sure that you guys write these down. Of course, I'm going to post this video, so you could always go back if you didn't have a chance to write these down. But so the people that are done, what I want you guys to do now, I'll leave it up there so you can see it, is I want you to analyze the following 6 equations. And I want you to tell me whether they're linear functions. If they are, tell me, yes, these are linear functions, and move on with your life. But if they're not, tell me why they are not. So if it's yes, just say yes, move on. If not, be like, no, because blah, 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 blah. So check this out, 1 through 6. Attempt to do these problems real quick, and then we'll go over them in not even about 2 minutes, because these are really, again, look and see. So try these out. So let's go over these functions and decide whether these are linear functions. So in the back of your guys' heads, what I want you guys to be kind of thinking of is, hey, are these equations going to give me a graph that's a straight line? Now let me look at this first one here. Now, just like as I mentioned before, the easiest way to figure out something is linear is to figure out or use the rules of why it cannot be linear. So for instance, our variables cannot be multiplied together. Now I have a single variable and I even highlighted it red so it can stand out to you. Is it getting multiplied by another variable? And the answer is no, it's only getting multiplied by a constant there. So we're good there. Check. Variables cannot appear in the denominator. Notice I don't even have any fractions, so that checks off as well. Variables only have an exponent of 1. Now notice that this variable doesn't have an exponent. Now luckily for us, if it's not written, it is a 1. So technically it's passed all these rules Now, 99% of the time, if it follows those through, if it does not, how would I say this? If it does not follow one of these rules, then it is linear, because if it does, that means it's not. So that means that yes, this is a linear equation. If you were to graph this, whether you're a graphing calculator or you're attempting, you would have a straight line. And that's what we're going to do. We're pretty much going to start developing strategies that, okay, these guys are asking me to graph something. I know it's linear. These are the strategies I'm going to use in order to do it. All right, number two. Let's go ahead and just go over the same list again. Variables cannot be multiplied together. Now notice I have x raised to the fourth. Now this is technically breaking two rules, but it might be a bit incognito. Variables can only have an exponent of 1. This variable has an exponent of 4. So no, this is not a linear function. It's going to give you something that's a parabola like this. But more of the story, what you can see too is that you're multiplying x by itself 4 times. So you can really explain why it's not using these two rules. I don't care, as long as you get your point across. So no, this is not a linear function. Exponent is 4. Something that lets me know, hey, the exponent is 4, or you're multiplying x by itself multiple times, lets me know that you understand. All right, number 3, notice that this is a function notation. So this is just a fancy way of showing function notation, but the moral story is that my function has 2 times x times y. Looking at all these rules, can variables be multiplied together? No, so this is not a linear function. Variables cannot be multiplied together. That's sells variables, by the way. Variables can't be multiplied together. Last one we can see here, or at least at the bottom one, y is equal to 5 over x. Is this going to give you a linear? And the answer would be no, because notice you're dividing by a variable. This is something that is called a reciprocal function. So it's going to give you something actually kind of cool. It's going to give you 2 of these little looking guys that you really don't cover until later on in math. This one's a little bit tricky. Notice that you have a variable. Is it getting multiplied by another variable? The answer is no. Does it appear in the denominator? No. Can variables have it? Variables can only have an exponent of 1. It has 1, so that means that yes, this is a linear function. Now, last but not least, I want you guys to tell me, anyone, what do you guys think? Is this a linear function? If I were to type this whole string of numbers into my calculator, would it give me a straight line? I think I heard everyone say yes, this would give you a straight line. Now, again, make sure you understand your rules. If you look at all these variables here, are any of those variables getting multiplied by another variable? And the answer would be no, because it's only getting multiplied by 4 squared and 3. So this one checks off. Is there any variables in the denominator? Nope, so that would check off. Do each and every single variable have an exponent of 1? Yes, so that means that yes, this would be a linear function. Don't get confused, because sometimes exponents on top of constants, they think it's variables. Don't be that person, to ensure that you're doing all right on these. All right, so just to reiterate, notice that down here, these 4 sets of problems, we have linear equations, or we might have linear equations. So the first thing you need to be able to do is to recognize linear equations and have a set of tools that you are going to use in order to help you graph these for whatever reason that might be. So the first strategy that we're going to go over to ensure that you guys are solid on when you get a linear equation and how to do so in terms of graphing is what is called standard form. Now, standard form are just linear equations written in the form ax plus by equals c. Now, the main thing that I want you to pull out from this statement is notice that your x and y are on the same side of the equation and everything else is on the other side, aka your constants. And notice that you still can be multiplying that x by a value, you still can be multiplying that y. But moral of the story, you're in standard form, your x and y are on one side and your constant is on the other. Now, keep in mind that your a, b, and c are integers whose greatest common factor is 1. So what does that mean for you? Whenever you have a greatest common factor of 1, that means that the only thing that divides a, b, and c is 1. So aka, in order to be in standard form, there should be no numbers that divide a, b, and c. And if it does, you need to know how to deal with it. We'll go over it in a second. Notice that your a AKA the value in front of the x is greater than or equal to 0. So it has to be positive. Your value of x has to be positive, and A and B both cannot be non-zero, because if they are 0, they're going to start canceling out variables, and then you won't have a linear equation. So these are pretty much the rules in order to get any linear equation into standard form. And then we're going to get that. We're going to use that information to help us graph. So it's a lot of information at once, but you'll notice that once you start doing these problems are pretty straightforward. And this is what I like to do in terms of making sure I'm in standard form. The first thing I start off with is making sure my A and my B are on the same side of the equation. So that's why I wrote a 1 there, to kind of help me visually see that, okay, that's your first step. So if I look at number 1, I know that this is a linear equation because it follows all the rules of linear equations. Now, is my x and my y on the same side of the equation? And the answer would be no. They are not on the same side of the equation. I need to get them on the same side of the equation in order to satisfy my first rule here. Now, keep in mind, and this is what's important, your A, that means that your value of x has to be positive. So that's going to tell me that I'm going to move this guy over to the other side instead of the y, because if I move the y, my A is still going to be negative. So let's go ahead and move that x value over. What I mean by move over is I'm going to add 2x to both sides, because if I add 2x on both sides, it's going to subtract out on the right side, and on the left side, I'm going to have 2x plus y. Now, these are different variables, so they're not like terms. So I'm just going to go ahead and write out their solution in a way, or write out the expression, which is 2x plus y. Now you can see that my x and my y are on the same side. I can clearly see here that x and y are on the same side. My x is positive. Notice that A and B are both non-zero. Keep in mind that this value here, this value in front of my y would technically be a 1, so I'm good there. Now, I'm also going to check to see if my greatest common factor is 1. Is there a number that divides 2, 1, and 3 evenly that's not 1? The answer would be no. So that means that I have finally done something I forgot to cover earlier, is that A, B, and C have to be integers, so you can't have fractions. But luckily for us, we don't have that in this situation. So is this a standard form? Yes. What would be the value of my A? Well, my A would always be in front of my x, which is a 2. My B would be in front of the y, which is a 1, and my C would be my constant on the other side, which is a 3. Again, I'm just looking at this from this angle over here. So that is a first example. I want you guys to go ahead and attempt to put number 2 in standard form, number 3, and number 4. Notice that number 4 is a little bit tricky, but I'll give you guys roughly, I don't know, about 2 minutes for number 2, and then we'll go over it. So remember, there are several ways of on what order to make sure that this is in standard form. I always like to do the same thing because I'm a super mechanical person. I always like to do 1 step, 2nd step, 3rd step. If I kind of leave it open, when I get to a test, I tend to struggle. So that's why I tend to do the same thing over. And the first thing I'm going to do is make sure that my x and y are on the same side. Now, for some reason, I'm a super visual person. I like to see everything on the same side. So I can see here that my x and y are in different sides. I want to get them over to the same. Now, it is up to you on which way you like to do it. The way I like to do it is I always like to look at my x first and see, hey, is it positive? And you can see here that it's negative. So I'm going to move it to the other side. Now, that's a positive 3/5 x. So I'm going to add 3/5 x to both sides. That is going to subtract the left side. Now, a lot of times people get confused. They're like, hey, I don't have anything left. Well, that's represented with the value of the 0. If notice on the right side, you can't really add anything. So I'm just going to go ahead and rewrite it over exactly the way it pretty much is. Now you clearly see here that my x and y are on the same side, but notice that that c, that constant, is not on the other side. So I'm going to go ahead and add 2 to both sides to end up with 2 is equal to 3/5 x plus 3y, and it's equal to 2. Now keep in mind that it doesn't really matter what side your x and your y are. As long as you have them on the same side. Notice that I kind of flipped them on the other end. That's going to be okay. Let me write that 5 a little neater. Now I am almost there. I have my x and y on the same side, but notice that my a, b, and c are not integers. Now remember, integers are just whole numbers. So unfortunately, I have to get rid of that fraction. Now, luckily for us, we have some experience with getting rid of fractions. Remember that all it is dividing by 5. So the opposite of dividing by 5 would be to multiply by 5. But remember, you have to multiply everything by 5. And just do the math afterwards. So let's figure this out. 5 times 2 is just 10. I'm going to write my response over here, or right here. 10. Notice that these 5s divide out, so you're left with a negative 3x. 5 times 3 would be a positive 15y. And then now you can see here that you have your a, b, and your c. There are no fractions, x and y on the same side. There's no number that divides all 3 of those evenly. So that means you're ready to identify your a, b, and your c. Your a in this situation would be the constant in front of your x, which is in this situation a 3. Your b would be the constant in front of your y, which is a 15. And of course, your c would be the constant that would be on the other side. So you can see here that you've identified your a, b, and your c, and you are good to go. So I'm going to erase all this work here to order to do number 3. Now, if I look at number 3 here, and they're asking me to put this linear equation into standard form, well, first I recognize that it's linear. Second thing, I notice that my a, b, and my c are not on the same side. Now, I do notice that my a, aka my constant in front of the x, is positive, so I'm going to move my y to the other side. So I'm going to minus 4y to both sides. I end up with 0 is equal to 8x minus 4y plus 10. And just like the problem before, I'm going to get rid of that constant and move it to the other side. So here I go, minusing 10. Negative 10 is going to be equal to 8x minus 4y. Now, checking back, I'm going to go ahead and see, okay, my a, my b, and my c are integers. My x and my y are on the same side. My a, aka my x, dividing by the x is positive. But is your greatest common factor 1? AKA, look at all this a, b, and c. Is there a number that divides all those numbers evenly that's not 1?
Yes,
Yeah, what would that be?
2.
2. So you have to make sure to divide them if possible. Negative 10 divided by 2 is a negative 5. 8 divided by 2 is 4. And then negative 4 divided by 2 is a negative 2. So now you are you are in standard form. So that means you can identify your a, b, and your c. Your a in the situation is 4. Your b, forgot my y by the way, is negative 2, and then your c is a negative 5. And that's pretty much it. That's all standard form is. Now notice that I really did try to trick you on this problem here. Let me choose a color that stands out a little bit more. Number 4. Notice I tried to trick you. Why did I try to trick you? Is this a linear equation?
No.
No, the answer is no, because you're dividing by that value or variable of x. Whenever you're dividing by variable x, you have something that's not going to give you a straight line. So with that being said, you cannot put this into standard form because it is not a linear equation. So you technically could just stop there. Now, that is about as far as I want to get. Starting on probably Friday, we'll start graphing these. But if you can get this down, how to change things, there's 2 things you're really learning here. One is making sure you can move variables around correctly. And 2 is getting them into standard forms. That way graphing is going to be a breeze on Friday. So let me stop recording.